Okay, so we're going to evaluate the following composite functions for radical 3x and 1 plus x squared. So, just like we did before, f of g, so g is going into f. So this whole thing is going into that x. We're just going to skip some steps. Probably won't solve it all because it's just basic algebra. So we have radical 3 plus 3x plus 3x squared. We're going to write that in descending order. So 3x squared plus 3x plus 3. We can also convert this whole thing into this. And we could always just distribute that in, canceling out what we don't need. Or we could just leave it be, or use quadratics also as well. So that one I'll just let it be. That one's not really bad. Once again, so now we're going to do 1 plus radical 3x plus radical 3x squared. That would cancel out. So we'd have, well, we can actually change him. And once again, this part's not really that bad. So you could just continue the math from there. So it's just really just solving. Composite functions is just whatever you see, f of whatever or g of whatever, or even f of f or g of g. Whatever's the second guy goes into him for x, and even specifies here for x. That's all that's saying. To write the inverse, to my knowledge, all you have to do is swap out x's for y's and y's for x's. Why is that? Well, reason being is f of x or y equal output. Okay, so these are the same thing, f of x and y. So right now it's f of x, that's the same thing as y. When you have x, this equals input. So basically you just swap out x's for y's and y's for x's. That would be the inverse. I really don't know any other way of explaining that, but yeah, that would be pretty much it. So now it would be x equals y minus 2. This one would be x equals 1 over y minus 1. That's, yeah, this isn't really crazy math right here. This is just very simple theoretical.